Good morning, sir.
Good morning, guys. Can you hear me? Do you see my video?
Yes, sir.
Yes. All right. That sounds good. All right, we're gonna start the class, but before we start, I need to introduce you guys to Miss Cherry Gel Figuration. She is basically with the Study Learning Group, and she wants to introduce you guys to a Study Learning Group. This is another supplementary, basically, classes that they provide with you guys, for you guys, so that you can basically learn more about MBF. And if you have any question about MBF, you can go to these people, and then they will help you with that. Okay, I will let Cherry take over from me, and then present her PowerPoint for you guys, introduce herself. Okay, Cherry,
right.
go ahead.
Yeah, thanks so much, Professor. Let me just share my
You're welcome.
PowerPoint. Yeah, you guys can see my PowerPoint, right?
Yes. Yes.
All right, thanks so much. So as Professor has mentioned, my name is Cherry. I am the SLG leader for the whole semester. I'm also doing ACC 106 and ACC 120. These two are both accounting. So if you guys have those two, you can also join my sessions for those ones, okay? So how will you guys find me? So these sessions are all online, okay? And you're gonna see this one in your Blackboard. It would say merge, and you will see multiple instructors, and that's where you'll be able to see me, and it will be in this link. Now, when you come to my sessions, you don't have to call me professor or miss or whatever. Just call me Cherry. because I'm also a student just like you guys. I'm in my third year of my degree doing accounting and finance here at Seneca as well. And I also did my diploma here at Seneca, but I didn't take accounting, I did tourism. And yeah, so you'll find me here. If you guys have any question, we'll probably take them up at the end so we can save time, okay? So the days that I'm available are this ones for MBF 100 and 101. We start together. So I'm available Tuesday, 11:40 to 1:25. I have Wednesdays as well, 2:25 to 4:10. And then Thursdays later, I have 10:45 to 12:30, which I don't think you guys could join in. So you can probably catch me up on Tuesdays or Wednesdays. So how it works is I am 1 week late from the professor's lecture. So for example, this week, you guys are talking about calculating terms and I believe it's equivalent and effective rate. Those topics, I will take them up next week. Okay, so I'm 1 week behind from the professor's lecture. So if you feel like in the middle of the semester, you're kind of struggling with the topics, you can always join my session. Okay, what else? So with these sessions, I mentioned a while ago that these are offered weekly, right? These sessions are not graded, so which means the sessions are not recorded as well. So yeah, okay, so these sessions are not recorded, so whoever comes in for our session, they'll be the only ones who get the benefit of whatever we're doing. Okay, the next thing, my favorite part about this is for free, so if you feel like you guys need help, you can always come in. Okay, next one, students who attend statistically earn better grades for MBF 101. Professor Maxime has given me the data that for this SLG sessions, those who attend get 13% higher marks. So 13% is like the difference from A to B. That's the difference from B to C. Okay. Next one is support historically difficult courses with DFW rate. So this DFW rate, what it means is those students who get a D from the course, the F, you should know. F means failed. You failed the course. And W is those who withdraw from the course without finishing it and not getting a credit from it. Okay. Lastly, they allow you to stay on top of your studies, which means you feel more confident and prepared for lectures, assignments, tests. With that being said, anything that is graded, if it's part of your test or your homework or your assignments, we're not allowed to take them up. Okay. Anything that is graded, that is with your professor. Okay. There's a few expectations in this session. Just be respectful, not just to me, but mostly your fellow students. Okay, because some people might be shy to ask questions or talk during the session. Or we want everyone to feel comfortable as much as possible. Okay, next one. We expect that when you attend the sessions, you also have attended your professor's lecture. So the sessions are not a replacement of your professor's lecture. So professor's lecture are top priority. Only the sessions are available only as a support. Okay. Yeah, just be prepared as well. Have your pen, your paper, also your BA2 plus calculator. And if the professors have assigned you reading, I would hope and wish you guys have read them as well. Okay. And yeah, that's pretty much it. I'm hoping I could guys see you in one of my sessions and you guys have a great day. Okay. If you guys have questions, I will stay for 5 minutes and you can direct message me on chat. Okay. Thanks so much, Professor.
All right. Thank you very much, Cherry. It's nice to meet you in the class. And I hope your support is going to help people to improve in their score. All right, so okay, so one thing I wanna mention, guys, is just very important that you do lab 1 and lab 2. I saw some of you guys didn't do any lab 1 and lab 2. So I just wanna let you guys know the people who didn't do those labs, their mark it's going to be 0. So basically, just make sure you do the lab 3, lab 4, because right now the course which we are covering right now is the time is running out. To really do those things in order to get the mark for your basically final score. So so it's important to do the labs, and also next week your test is going to be open. So test 1 is going to be open. Very, very important, guys. Test 1 is open next week from February 6 to February 9. You need to do the test during that period, right? So you have only 90 minutes for that test as well. Just practice a lot with the mock test first, okay? So you have a mock test 1, try it a lot, practice it a lot. And next week I'm gonna be also in the next week lecture. We're gonna it's gonna be only question and answers, right? So if you have any questions, bring it next week to the class, so that we work together to solve those questions. So next week is going to be question and answer session. Okay, before you take your test, I believe you can basically come with your question, and then we solve it together. And that's very important. As I said, next week is going to be test 1. You need to prepare for that. You need to basically take the test. That's 25% of your final mark. And also the labs. Please guys, do the labs. Do that. Don't leave it behind. Don't say, okay, I'm gonna do it later, and then the time is running out. And the deadline for the labs basically expired, and then you don't do it, and then the mark is gonna be 0. Okay, so it's very, very important, guys, to do this. Okay, all right. So I'm gonna start basically sharing my presentation today, and we go from there. Okay. Any question? All right, no question, means everyone knows. All right, so do you see my PowerPoint?
Yes.
Yes. All right, sounds good. All right, so in this session, we're gonna discuss how to calculate the number of component periods and time period, okay? So in previous session, we were talking about how to calculate the future value. We talked about how to calculate present value, and also how to calculate the periodic interest rate and nominal interest rate. So in this one, we're going to discuss about how to calculate the component period and time period. Okay, these all follow the same equation. Future value is equal to present value 1 plus I power of n, and I is going to be periodic interest rate, and n is going to be number of component period. So still be using the same equation. Previously, we had PV, I, and N. We calculated future value. Then we changed the equation so that we had future value, interest, and N. We find present value, and then we another configuration of the questions where we had basically future value, present value, and N. We find interest rate, and now here we have future value, present value, and interest rate. We want to find N. Okay, so how do we find N? Okay, so how do we find number of component period and the time period associated to it? Okay, how do we do it? We need to isolate the both equation for N, right? So we want to isolate N. We want to extract N from this equation. Okay, so we presume that we have future value, we have present value, and we have interest rate, periodic interest rate. We want to just find what's going to be a number of component period, which is N. Okay, so how do we do it? We need to isolate it for N, and so first of all, we have to get rid of everything which is coming with N here on the right side. So first we get rid of the PV. So we divide both sides of the equation by PV. So then the PV is gonna eliminate it from numerator denominator here. Then we're gonna have 1 plus I power of N is equal to FV divided by PV. Now we have to, as I said, we need to extract N. How do we extract N? We need to get a function so that the N is gonna become a multiplier rather than a power. And that function is the natural logarithm. The natural logarithm function is so that when you use it, the n from the power is going to come to the become a multiplicator rather than the power. Okay, so natural logarithm of x power of y is going to be y natural logarithmic of x. Okay, so that's how it works. And then how to basically isolate n. So n is going to be basically natural logarithmic of fv divided by pv divided by natural logarithmic of 1 plus I. Okay, so that's how we find the number of compounding periods. So n is going to be ln fv divided by pv divided by ln 1 plus I. So that's how we find the number of compounding period. And what's going to be the time period? Time period is going to be basically time is going to be n number of compounding period divided by compounding frequency, right? So if you divide, then we find time as well. So as I said, the questions here, they ask for time. Okay, so how many years is going to take to do this? How many years is going to take to do that? And they give you future value, present value, and interest rate. Okay, so they want to find time. So you learn how to find time, right? So first you find number of compounding period using this equation, and then using this equation you find time. Okay, t equal n divided by m. Okay, so let's do some example. Any question until now? All right, no question.
Excuse me,
Yeah.
I have a question.
Yeah.
What does that ln means?
Ln is natural logarithmic function. Natural logarithmic function, like logarithm function, but it's natural base. I believe you learned it in high school. So if you don't know anything about natural logarithmic function, probably you need to look at your textbook. There should be a portion about description of natural logarithmic function. And if it's not like that, it's very, very basic, like exponential function. You know exponential function? It's,
Yeah.
It's just the inverse function of the exponential function, e power of x, and then ln of x. So is ln is natural logarithmic function, which is a logarithm function at the base of e, which is basically exponential function. Yeah. So you need to just look at your textbook, or even go to high school math, find what's the ln function is. Okay. So
Okay.
and ln function in your calculator, I'm just going to show you in the calculator where is the ln function is. Okay. So let me create this mode. Let me do this. So this is ln. Do you see the calculator right now? ln. This is ln. Yeah. So you like 7 ln of 7 is 1.945. Okay. You see this ln function? Yes. No.
Yes.
Yeah. So 3 ln is equal to this. And if you want to do if you want to do inverse of an e power of x, you use this. Okay. You use 2 second ln. When you do second ln, means e power of x. You 2 e power of x. Okay. So 2 like 3 second e power of x. So e power of 3 is going to be 20. E power of 1 is going to be e, right? E power of 1 is 2.7182, right? So this is the e number. And ln is the inverse of e exponential function. So, okay, the ln function.
Okay.
All right. So, okay, let's solve some example here. Okay. How long will it take for an investment of $25,000 to mature to $85,000 if it grows at the rate of 10% compounded semi-annually? Run your answer to the next nearest month. Okay, next nearest month, guys. Okay. So in this example, they give you the future. They give you the present value. They give you the future value, and they give you interest rate. So what they ask is how long it will take. So they ask for the time. Okay. So as we said, we have all this information here. We need to use the equation which we learned, ln fv divided by pv divided by ln 1 plus I. First of all, we need to find what's I. I is going to be j divided by 2, right? So semi-annually, means your compounding frequency is going to be 2, and 10% is going to be your nominal interest rate. So the periodic interest rate is going to be 0.05. Now we're going to use this equation as we learn it. We have future value, $85,000. We have present value, $25,000. And we have I, which is 0.05, okay? So we put it together. Let's do this in calculator, okay? ln $85,000 divided by $25,000 divided by ln 1 plus 0.5, okay? Let's do it in calculator. 85, okay, so ln of this guy, okay? So $85,000, make sure, do this, okay? $85,000 divided by $25,000 equal to, first, we need to find what you have inside this, okay? 85,000 divided by $25,000, okay? That's going to be 3.5. You put the ln of this guy, it's going to be 1.2237, okay? So let's store it at number 1. So we have the numerator stored at number 1, and then we have the denominator 1.05, right? So do that 1.05 ln and store it at number 2, okay? And now we have to divide these two guys together, which is recall number 1 divided by recall number 2 equal to, this is going to be the answer, okay? 2508, okay? So that's how we do it in calculator, okay? You can do alternative ways. It just depends on you how comfortable you are with the calculator. But that's the most easiest way, right? So you store the denominator on number 1, you store denominator on number 2, you recall 1, and then you divide it by recall 2, okay? So that's going to be number compounding period. It's going to be n, and then from n we want to find what's the value of t, right? So t is unknown, right? Number of years, right, is unknown. So we have n, and how we get from n to t, n divided by n divided by compounding frequency, which is 2, is going to be t, okay? So compounding frequency in this case is 2. It's going to be t. So t is going to be 12.54 years. But ask to the nearest month, okay? So how can we do it here? We need to separate 12 years from the rest of it, 0.54, whatever it is in years, and we have to multiply whatever it is in years by 12 to make it months, okay? So it's going to be 12 years plus 6.4954, whatever, in months, but it said next nearest month, means the next month. So means it has to be 7, okay? Next nearest month, so 7 months, okay? So the next nearest month, not previous nearest months, next nearest month. When it said next nearest month, means you have to run the number to the higher number, okay? So it's going to be 7 months, okay? Any question here? All right, no question means we learn it. Now let's do it in calculator mode, okay? So in calculator mode, let's do it together in calculator mode, okay? So what we have here, we have let's go for the calculator. We have $25,000 as initial investment. So present value is going to be, okay, so let's first of all clear everything in calculator. So we have clear everything in the calculator right now. So now this $25,000 is going to be initial investment, right? So the present value. As I said, make sure the sign for present value is different than the future value. Otherwise, calculator is going to give you error, right? So the present value in here, since this is investment, has to be negative sign. So present value is going to be minus $25,000, yeah? And then what's the future value? $85,000, right? So $85,000 is going to be your future value, yeah? So present value, we said present value, we said future value. Now we need to set basically the number of compounding period, which we do it. So number of compounding periods in this case, sorry, I'm so sorry. We need to find you need to set the compounding frequency, okay? The compounding frequency here is is semi-annually, right? So compounding frequency is going to be 2. So let's do compounding frequency. Second I over y is going to be y, right? So it's going to be 2 set, okay, and then second quit. You remember about how we set the compounding frequency, right? So we do second I over y, which give you p over y. P over y is compounding frequency. You set it to 2. You set it to 2, and then you come out. So one more time, second p I over y, give you p over y. This is compounding frequency, guys. You set it to 2, enter. It's going to be set, and now you quit from that p over y mode. Okay, second quit. Okay, and now okay. So we set FV, we set PV, we set compounding frequency, and also we need to set the 10% component semi-annually. So we need to set the I over y as well, which is interest rate, nominal interest rate. So that's we also set. So now we set everything except n. We need to find what's n, right? So we do CPT n. So n is going to be 25.08, right? So n is going to be 25.08 as we find it here. And now this is n, right? So from n, we need to find t, right? So the rest you can do it by hand. We divide the n by 2. It's going to be this number of years, and it's going to be 12 years, and then the remaining of this guy by 12, which is going to be 6.49. It's going to be this one. Okay. So in calculator is easier to do it because the calculator is already have the formula inside it, basically hard written, and you just need to set the values, set the three values, and find the fourth value, right? That's calculator is going to be easier, but some of you guys might be more familiar or more comfortable using pen and paper and the formula. It's up to you guys. It's just whatever you want to do, it's fine. Okay. Any question until now, guys? Any question? All right. So
Hello,
let's do.
Professor.
Yes. Yes.
Would you please explain about the different steps in using a calculator? Because I want to do that with you. With
Sure.
my
Yeah.
Mhm.
All right. So in calculator, okay, which value we have to set? Okay, future value, present value. So what's the value? What's the basically important 4 components that we have to set in calculator? Okay, like we have 5 components we have to set in calculator for this, right? We have present value, we have future value, we have nominal interest rate, we have number of compounding period, and we have compounding frequency, right? So these are five different things we need to set in calculator, okay? But okay, so these are 5 different things that we can set theoretically in the calculator. But if we set 4 of them, the 5th is going to come, is going to be calculated automatically, okay? So for example, in this case, we want to know what's n, right? So we need to set FV, PV, I over y, and P over y, okay? So P over y is compounding frequency, I over y is nominal interest rate, PV is present value, FV is a future value, okay? If you set all those for quantity, the 5th quantity, which is n, is going to be calculated using CPTN, okay? So you calculate CPTN, okay? So this is just a universal thing, right? You can also, what you can also do, you can set also n, PV, FV, and compounding frequency, find interest rate. That we did it in the last session, okay? Or you can also calculate the present value, or you can calculate future value, okay? These are all available in the calculator methods, right? So they're all available in calculator. It's hardcore written in calculator. So so all the equation basically are written in the calculator. So you can basically use calculator to calculate any of those guys. For example, if I right now I have a PV of 25,000, FV of 85,000, I over Y of 10%, and N of 25. Okay. If I change the n, for example, to 50, okay? Now then I presume that I over y is still 10% and a present value is still $25,000 and compounding frequency is still 2, then I can calculate FV. FV, future value, is going to be very different right now, right? So it's going to be $286,000, okay? So what I mean here means that you can set 4 quantity and find the 5th quantity using the calculator. That's all I mean, okay? And the 4 quantity are PV, FV, nominal interest rate, N, which is number of compounding period, and P over Y, which is compounding frequency. Yeah. And how do you set them? As I said, you put 25,000, for example, for this exam, 25,000 with negative sign for present value. Make sure the sign for present value is different than the sign for future value. Future value sign has to be different than the present value. $85,000 for a future value, right? Let's go to the example. A $25,000 present value, $85,000 future value. Nominal interest rate 10%. 10% is nominal interest rate. And now compounding frequency is going to be 2 semi-annually. Compounding frequency P over Y is 2. Set. You quit this mode. Now you set everything. Now you do CPT-N. You calculate U N. So N is 25.08. Okay, 25.08. And now from 25.08, you want to know what's the time, right? So time is going to be N divided by compounding frequency, which is going to be 12 point whatever years, and you have to convert this whatever years to months, okay? Which is going to be like this, okay?
Yeah.
You understand it?
Thank you, Professor.
Yeah.
Sir, I wanted to ask, like, since it's 6.49 and
Yeah.
not 6.5, like, why isn't it 6 months? Like, why are we rounding up?
Okay, look at the question. The next nearest month, not the previous nearest month. Next nearest month. So you have 6.49, right? You are already in the months. You want to do the next nearest month. Next nearest month. Okay. Question. Yeah. Round your answer to the next nearest month. Next. Yeah.
Yeah.
You got it?
Yeah, I do.
All right. So. All right. Any other question? Did that calculator review was good? Do you have any question? Yeah. All right, so let's do example together. I give you guys 5 minutes for this. What's the term for an investment of $2,000 that earn interest of $500 at the rate of 7.5% compounded annually? Okay. Run your answer to next nearest month. Okay. I'll give you 5 minutes for this. All right, let's look at the answers here. So we got the letter A, letter A. Okay, I hope the A is right. Let's see. Yeah, A is right. Perfect, perfect. So very good, guys. Okay, so let's look at the solution. Okay. Okay, so the question is, what's the term of investment of $2,000 that earns interest of $500 at the rate of 7.5% compound amount annually, right? Okay, so we know the present value, right? The present value is $2,000, right? What's the future value? We know the interest, right? So interest plus the present value is going to be future value, right? So is future value is going to be 2,500, right? So present value is 2,000, future value is 2,500. The rate we have 7.5% compounded annually. We need to find I, right? So I, which is going to be a periodic interest rate, we need to find it first. So it's going to be periodic interest rate. It's going to be nominal interest rate divided by compounding frequency, which is 2 in this case. Since it is compounded annually, means compounding frequency is going to be 1. So I is going to be 0.075. So now we have future value, we have present value, we have I. Then we can use this equation, right? So we find N. N is going to be ln F3 divided by PV divided by. Let's do it one more time using calculator to calculate this number. ln 2,500 divided by 2,000 divided by ln 1 plus 0.075. Okay, let's go to calculator and do it. So let's clear everything. 2,500 divided by 2,000, right? $2,500 divided by $2,000 is equal to this. And now we need to get the ln of this guy, ln. Okay, and we store this guy at number 1. So this is stored in number 1 slot. Okay, and now this guy 1.075. 1.075. We get ln of this guy as well. We store it at number 2. Yeah. And now we need to divide recall number 1, which was the top one, divided by recall number 2, equal to 3.085. 3.085. Okay. So that's going to be N, right? So N is going to be 3.085. And now what's going to be the T? T is going to be N divided by M, which is compounding frequency, right? So in this case, compounding frequency is going to be 1 because it's compounded annually. So it's going to be this number of years, right? So this number of years has to be converted to months, right? So 2 years we don't touch it, but this guy need to be converted to months, right? This guy need to be multiplied by 12. So you multiply by 12, it's going to be 1.02. It's a little more than a month, right? And it said next nearest month. That's why 2 months is right. So I see some people make a mistake, put it 1 because they say, oh, okay, this is ignorable. This is 1.02 months, right? It's not even a day. It's not even a day. Yes, that's nearest month. Yeah, guys, we need to put it nearest month. Next nearest month. Next. Okay, that's good job, guys. All right. So let's do it in the calculator way. Again, let's do it in calculator way. Okay, so we have present value of $2,000. Let's do it. Let's clear everything first. So make sure you do second clear TVM so that you have calculator cleared everything. So second clear TVM is going to clear the whole memory of the calculator. And now you have present value of $2,000, which is going to be $2,000 negative. Make sure you have negative sign in front of present value, guys. If you don't do it, the calculator is going to give you error, and they say, "Oh my God, why did the calculator give me error? Oh my God, I said everything right. Why this is giving me error?" And the problem is just you have to put the PV sign negative and FV sign positive. The signs have to be different between PV and FV. Okay. So $22,000 negative. FV is 2,500, right? So 2,500 is going to be, oops, sorry. 2,500 is going to be future value, right? So we set future value, we set present value. we need to set nominal interest rate, which is going to be 7.5%. So 7.5%, 7.5% is going to be I over Y, nominal interest rate, right? And now we need to set the compounding period, right? It's the compounding frequency. What's going to be the compounding frequency? It's going to be 1, right? So second compounding frequency, P over Y, is 1. Okay, set. So now, and then you come out. You come out. Second quit. Okay, you have to come out the P over Y mode. Okay, your compounding frequency mode. Quit, and now everything's set. You need to only calculate the N. N is going to be this guy. Okay. N is going to be 3.08, and if you subtract 3 years from it, you're going to be this number, which is going to be in months, and then you multiply by 12, which is going to give you in months. Okay, so it's going to be 1.02. You should round it to 2. Okay. Yeah. Any question? Any question, guys? All right, so we're done with this part. We need, I'm gonna move to next PowerPoint, which is, we discuss basically equivalent interest rates. So I will close this. If you don't have any question, we move to the next part of the lecture. We discussed that for like 20 minutes. And then before we go to effective interest rate, we take a break, okay? Any question on this, guys? No question? All right. I'm just going to close this and open this guy. Do you see this?
Yes, Pastor.
Yes.
All right, sounds good. All right. All right, so the last part of compounding interest rate lecture is about calculating equivalent interest rate, okay? So this is the last part of this lecture, and then the topic which we covered until now, they're gonna come to your test. Like test 1 is gonna be included everything which we learned until end of today, okay? And one more time, I wanna emphasize that you only the test 1 basically this one is going to be opened next Monday, and it's going to be closed next Thursday at midnight. Okay, we have another meeting next Thursday, right? So you can either wait until we finish our meeting next week, so you have all your questions that are answered next week, or if you're comfortable, just go ahead and do the test 1 yourself without waiting for next week's session. But next week's session, as I said, it's going to be question and answer. So if you have any question, just come to me. We bring your question to class, and then we basically work together to solve that question. Okay, that's going to be next week session. And one more thing I want to say and emphasize that do the mock test, okay? At least a couple of times. Do the mock test before you do the test 1, because the mock test is gonna prepare you for the test 1, okay? So test 1 is gonna be similar to mock test, okay? In terms of structure. So mock test, practice it as many times as you can. When you get very familiar, when you get very comfortable, basically doing the test 1, then do the test 1, okay? At least do a couple of times a mock test to make sure that you're comfortable with it, okay? This is one thing. Also labs, guys. I see a few of you guys didn't do the lab at all. So your marking lab is 0. Lab 1 and lab 2 time is over, expired, so you can't even touch them anymore, and you lose like 5% already from your final mark. So make sure you do the labs as well, like lab 3 and lab 4 before they expired, okay? That's very, very important, guys. Okay, thank you. All right, so let's talk about equivalent interest rate. Okay, so what's the equivalent interest rate? Equivalent interest rates are nominal interest rates with different compounding periods. Okay, that result in the same future value for a given principal value for any fixed period of time. Okay, so in other words, if you have a present value like $1,000, okay, you put it in a bank, okay, and after a year you have $2,000 as a future value, okay, but it's possible. So bank tell you you can either use this interest rate with this compounding frequency, or you can use this interest rate with this compounding frequency. But they are all both the same. So they give you both the same future value. Okay. So basically, the concept of equivalent interest rate is that you have two different interest rates with two different compounding frequency that give you the same future value if you have the same present value over the same period of time. Okay, so that's the concept of equivalent interest rate. So then we say, okay, this interest rate is equivalent to this interest rate with this compounding frequency. Okay. So why they are important? Because sometimes you need banks need to calculate what's the effective interest rate, what's the equivalent interest rate for some investment. So they wanna know what's the basically so this is important also for accounting as well. So you need to basically know what's going to be the equivalent interest rate for that specific interest rate which you basically charge the client. Okay. If you work for a company or work for a bank, so something like that. Okay. So as I said, it's just so how do basically calculate one versus the other is that basically so you basically wanted to find I2 versus I1. So in question they give you I1 with the compounding frequency, and they ask you what's I2. Okay. And how do you calculate the I2? You just need to basically isolate I2 from both sides. And how you can do it, you just basically both sides of the equation you put power of 1 over m2, and then this kind of m2 over m2 is going to be 1, so I2 is going to be like this, and then I2 is going to be 1 plus I1 m1 divided by m2 minus 1. So I2, which means equivalent interest rate of 2 is going to be 1 plus I1, which is interest rate of 1, M1, which is going to be compounding frequency for I1, divided by M2, compounding frequency for I2 minus 1. Okay, so that's how we calculate the equivalent interest rate to the specific interest rate that is given you in the question. So in the question, they give you a specific interest rate with a specific compounding frequency, and they're going to ask you what's going to be equivalent interest rate of this interest rate if we change the compounding frequency. Okay, because that's a configuration of the questions they ask you. It's going to be like this. So they give you the I1, they give you the compounding frequency for I1, and they say, okay, what's going to be I2 if we have different compounding frequency? So you use this equation to find I2, and after you find I2, you can find J2, right? So after you find I2, J2 is going to be compounding frequency 2 multiplied by I2. Okay, we go through a question, you will get familiar with this concept. Okay. All right. Okay. So, for example, there's an example: 6% compounded monthly is equivalent to what rate compounded quarterly? Okay. As I said, they give you I1, they give you M1, which is compounding frequency for I1, and then they give you M2, which is going to be compounding frequency for I2, right? So M2 is going to be quarterly, like 4, right? And then you will find they ask you what's I2 and then J2 basically. Okay, so that's basically the concept of how these questions are structured based on this. So they give you I1, they give you M1, and they give you M2. They ask you what's I2. Okay, so so let's solve this question. Okay, so first of all, this is J1, right? So this is J1. You need to find the I1. Okay, so. Okay, so J1 is going to be 6%, M1 is 12%, so I1 is going to be basically 0.06 divided by 12, right? So J1 divided by M1, and you have this, and then you use the equation, right? So the equation is going to be I2 1 plus I1 power M1 divided by M2 minus 1, and in this case you have I1, which is this number. You have M1, which is 12. You have M2, which is 4. And you find I2. Okay. Let's do this in calculator. Okay. Let's do this in calculator. 1 plus 0.06 divided by 12, power of 12 divided by 4. Okay. I'm just gonna make you guys more familiar with calculator. Okay. Okay. Let's do this. 1 plus 0.06 divided by 12 power of 12 over 4. Okay. So let's clear everything. 0.0. Okay. So first of all, we need to find the base first and store it in number 1. We find the power second and store it in the number 2, and then we do the y over y power x. Okay, so let's do this first. 0.06 divided by 12 plus 1. Make sure you do the division first and then addition after that. Okay, don't do 1 in calculator plus 0.06, because as soon as you do 1 plus 0.06, it's going to add these two numbers together and then divide by 12. So it's going to be wrong number. Okay, first you do the divisions, 0.06 divided by 12, and then add it to the 1. Okay, make sure you do that in calculator. So 0.06 divided by 12 plus 1 equal to this one. Okay, 0.05 is stored at number 1. Okay, so we have this guy. This guy is stored in number 1 calculator. 12 divided by 4, which is going to be 3, right? But if we do it like this, 12 divided by 4, it's going to be 3, stored at number 2 in calculator. So we have this guy stored in number 1, this guy is stored in number 2, and then recall number 1, power of recall number 2 is equal to this guy. Okay, and then minus 1 equal to this. Okay, so 0.015075, whatever. Okay, and that's going to be I2, right? So I2, which is interest rate, quarterly interest rate, periodic interest rate, is going to be this one. And then we need to find J2, right? So we want to know what is the nominal interest rate compounded quarterly, right? So J2 is going to be M2 multiplied by I2, which is 4 by this, and this is going to be this, and it's going to be 6.03%. Okay. Any question here, guys? Any question? All right, no question means good. So as I said, they give you I1, they give you M1, and they ask you for I2, which you can use this equation, and then J2 is going to be compounding frequency multiplied by I2, right? So, all right. So okay. So in calculator method, there's a method here. I don't want to explain this now because it's gonna confuse you more, because it is effective interest rate. We haven't discussed this yet, so we will come back at the end of lecture if you have time to this question. Okay, but I just don't want to use right now because we haven't discussed the effective interest rate. It's going to make you more confused if I explain this. Okay, in the calculator method. But we come back to this. Okay, don't worry about it. Okay. All right, so let's solve another example. I give you 5 minutes for this. So 7% compounded semi-annually is equivalent to what rate compounded daily? I give you 5 minutes for this. right, so I got a lot of A here too. Let's see if the A is right. Okay. Yes, A is right. Yeah, congratulations to you guys. Okay, so how can we calculate it? Okay, so let's do it. Let's do it let's do the solution. Okay, so all right, so we have 7% compounded semi-annually, right? So J1 is going to be 7%, right? So, and semi-annually means compounding frequency is going to be 2, right? So compounding frequency 2. And now we want to know what's going to be I2 or J2, sorry, J2, if we have compounding frequency of 365, right? So first of all, we need to find I1, right? So I1 is going to be 0.07 divided by 2. And now we use this equation. I2 is equal to 1 plus I1, power of M1 divided by M2 minus 1. So we have I1, we have M1, we have M2. Just put it there, okay? So how do we calculate this? Again, let's go through the calculator. 1.07, 1 plus 0.07 divided by 2, the power of this. As I said, if we find the base, we store it in number 1 in calculator, we find the power, we store it in number 2, and then we do base power of power, right? So that's how we do in calculator. But as I said, make sure you do the division first and then add to 1, okay? If you do in calculator 1 plus 0.7 divided by 2, you will get different result than 0.07 divided by 2 plus 1, okay? It just get different result because when you do 1 plus 0.07, it add 1 with 1 with, okay, so it's gonna add 1 with the 0.07 and then divided by 2, which is gonna be 0.5 whatever, okay? And that's very different than 0.0335, right? So that's different. So this is important, guys. First the divisions and then summation, guys. Divisions and summations. If you have multiplication, first multiplication and then summation, guys. It's very important. Calculators are dumb, so you can't rely on calculators. You have to make sure you do it properly, okay? So if it's like 0.07 multiplied by 2, you have to also do the multiplication and then summation. Multiplication and divisions are first priority, okay? You do them first and then you do the summation or subtractions, okay? That's very important. Rule number 1 of using calculators, okay? So let's do it here, okay? 0.07 divided by 2 plus 1, which is gonna be 0.07 divided by 2 equal to plus 1. It's gonna be this one. 1.035, you store it in number 1, yeah? You store this guy in number 1. 2 divided by 365. 2 divided by 365 equal to, you store it at 2, yeah? And now 1 power of 2, right? Recall number 1, power of y over x. You see y over x, power of. Recall number 2 equal to this, okay? And then minus 1. And then minus 1 equal to this guy, okay? This guy. This is going to be per day, right? So I2, you will find I2. I2 is going to be per day, right? And then to calculate J2, you have to multiply I2 by M2, right? So J2, the nominal interest rate per year, is going to be compounding frequency M2, which is 365, multiplied by I2, okay? So you multiply this together. So multiply by 365, it's going to be this one. And that's going to be nominal rate. You have to multiply by 100 to find the percent, 6.88, okay? So that's going to be 6.88%, okay? So that's going to be like that. And then any question until now, guys? Any question? All right, so I'm going to tell you about the calculator method very briefly, although it is not, we need to discuss the effective interest rate first, but let's do it in the calculator method, okay? So in calculator also you have, let me clear everything here. In calculator you have an option to basically calculate the effective interest rate. So what's effective interest rate is? Effective interest rate, we're going to discuss it in the next part of lecture, but just briefly, effective interest rate is the equivalent interest rate which is compounded annually. Okay, so as I said, these interest rates are all equivalent, right? So all these interest rates are equivalent, right? So for example, for this guy, 7% compounded semi-annually, you can find the effective interest rate. An effective interest rate is going to be an interest rate which is compounded annually, okay? The nominal interest rate is compounded annually, okay? And that's built in the calculator, okay? So you go to calculator, you press second iconv, okay? Second iconv, and you are in the effective interest rate mode, okay? And what does it mean? You can give the nominal interest rate. In this case, it's like 7%, right? 7% set, okay? And also you can give the compounding frequency C over Y. Use arrow keys, okay? Use arrow keys, C over Y, compounding frequency 2, set, okay? And then you go to effective interest rate and CPT. When you do CPT, you can find effective interest rate for that interest rate, 7 and 2, right? For nominal 7 and compounding frequency of 2, you can find the effective interest rate, okay? So nominal of 7, compounding frequency 2, what's the effective interest rate is 7.12, okay? So effective interest rate is the interest rate which is compounded annually, okay? And now if you basically so this is built in the calculator, okay? So you give the nominal interest rate, you give the compounding frequency, you give you the effective interest rate, okay? And now so this effective interest rate, as I said, is equivalent interest rate to that nominal interest rate, right? So now we wanna change the number of days, right? So we want to change the compounding frequency with the same effective interest rate. We want to know what's going to be the new nominal interest rate, okay? So we change the compounding frequency to 365, and now we want to know what's the new nominal interest rate. We do CPT 6.88. So 6.88 is a new nominal interest rate with the different compounding frequency, okay? 365, okay? So that's basically how we can use calculator as well to solve this question. So basically, effective interest rate, as I said, is the equivalent interest rate to whatever you give as nominal interest rate and compounding frequency, and since that's equivalent interest rate, you can change the compounding frequency, find the new nominal interest rate. Okay. We will get to the effective interest rate in next part of the lecture, but first just bear with me that this is like that, okay? All right, so I'm gonna basically take a break here for you guys, because we are entering new subject of effective interest rate just in more detail, with some more examples there. We need to discuss the effective interest rate very thoroughly from now on, and we will reconvene basically in 15 minutes. If you have any questions, let me know before we leave. Do you have any question until now?
Sorry,
All right,
would you please show again how to use the calculator to do the effective interest rate? Because I just missed the first step.
All right, so the effective interest rate is basically you set the nominal interest rate. Okay, so let's first of all, let's just quit this mode, clear the word, clear TVM. Okay, you push second iconv. Okay, iconv number 2. Okay, second number 2. You are right now in the effective interest rate mode. Okay, and in the effective interest rate with these cursors, like arrow down, you have three quantity: num, f, and c over y. Okay, you have 3 quantity. So what you can do right now, you can set your num to like 7%, right? Enter. Set your C over Y, which is your compounding frequency. In this case is 2, right? Compounding semi-annually, 2. Enter. And then arrow down, so arrow up key, you get to effective CPT. When you do CPT, it calculate you the effective interest rate, which is equivalent to this compounding frequency and this nominal interest rate. So if you have this nominal interest rate and this compounding frequency, you will have this effective interest rate. Okay. Yeah. So that's how you calculate the effective interest rate. Okay. You understand this? Yes. No.
Sure, thank
Hello?
you. Yeah.
Yeah. All right. Yeah. So that's how you calculate effective interest rate. Yeah. So okay. I'm just gonna give you guys another a 15 minutes break, and maybe we'll come back at 11:17. Let's say 11:20. Okay. We'll come back at 11:20 to discuss the next part of the lecture. Okay. All right, guys. See you in 15 minutes. Okay. All right, guys. Yes, Yasin. Okay, so you're having good question. Can anyone please tell me how to find MBF all recorded classes? Okay. All right. So I'm guessing you have Zoom account on Seneca, right? So you go to Seneca. Okay. So let me share my screen first. Yes, so you go to Zoom, senecacollege.ca, .zoom.us, recording, okay? So you go to recording part and you search the meeting by meeting ID, okay? I believe your ID is, we are in ZAA class, so basically that's your meeting ID. If you don't know what's the meeting ID of the class, just go to your Blackboard, and on Zoom meeting you will find basically the ID for the meeting, which is in this case is 958-4628-5901. And if you search that thing in the Zoom, you should be able to find it. Okay, enter. Yeah, so this is basically how you find the how you find basically the recording in the Zoom meeting. Yeah. Yeah. Any question? All right. All right. Thank you. Thank you. Thank you as well. All right, I'm just gonna basically share my screen and continue with where we left. All right. All right. All right. Okay. All right. So what is effective interest rate? Okay. The effective interest rate, F, is the annually compounding interest rate. Okay. So the effective interest rate is used to compare the annual interest rate between loans and investment that have different compounding period. By definition, the effective interest rate, F, results in the same future value as a nominal rate with a given compounding frequency. Okay. So, for example, here you put your money in the bank. Okay, you put $100 in the bank. Okay, and bank tell you they're gonna give you 1% per month compound. Okay, they're gonna give you 12% 12% compounded monthly. Okay. And you say, okay, I just don't want to know how much you tell to the bank, okay, it is so complicated for me. I don't want to know. I don't want to basically. I just want to know how much I'm gonna get after a year. So I just don't want to know what's compounding monthly. Every month I have to put $100 there, and then at the end of the month I have to take out my money with the principal. It's just very complicated for me and confusing for me. Can you just tell me what's going to be my effective interest rate? Means how much I'm going to get after the year of putting my money in the bank. Okay. And then bank tell you, okay, it's no problem. I'm just going to calculate for you that very easily. Okay. And then they use this equation which you guys can see it. Okay. So they use this equation to convert any kind of interest rate, any kind of compounding period, to effective interest rate, which effective interest rate means that how much interest you get, how much interest you get at the end of the year. Okay, at the end of the year with compounding frequency of 1 year. Okay, just one. So annual compounding frequency. So basically, effective interest rate is equivalent interest rate to any kind of interest rate you're given with any kind of compounding frequency. Okay, and make it life much easier, right? So you don't wanna deal with all the different number and different compounding period when you put your money in the bank. Okay, so you just want to know what's going to be the effective interest rate for your money, right? So that's basically how it's calculated. So effective interest rate is going to be 1 plus I m minus 1. If you remember, if you put the I2 and I1, it was I2 equal to 1 plus I1 M2, M1 divided by M2 minus 1. In this case, M2 is equal to 1. Okay, so since M2 is equal to 1, we can get rid of M2, and also I2 is equal to J2, right? So because M2 equal to 1 means I2 and J2 are equal, so then we immediately can put the effective interest rate or J2 here. Okay, so that's how we calculate the effective interest rate. Okay, and in the calculator, let's go to the calculator mode. I'm going to show you in the calculator. Calculator, and how do we do it in calculator? We already discussed this before we finished the last lecture, but let's discuss it one more time. I quit from that mode. So second, number 2, iconf give you 3 options: nominal, effective, and compounding frequency. Nominal, compounding frequency, and effective. So you basically set your nominal interest rate like to 10%, for example, with the compounding frequency of 4 quarterly, and then you go to effective and push CPT. CPT is going to give you effective. As I said, 10.38. So as I said, it gives you effective interest rate, which means that how much interest you're going to receive annually, and it is basically compounded annually. Okay. So basically, as we said, it's going to be like this, using the calculator method. Which of these are true for nominal and effective interest rate? Okay. Okay, so basically, effective interest rates are nominal interest rate compounded annually, right? So nominal interest rate compounded annually is effective interest rate. This is true. And also, nominal interest rate is the quoted or shared interest rate. That's right. So this is basically a stated interest rate. So it's stated interest rate. That's right. Why B is not right? Effective interest rate compounded annually is the nominal interest rate. This is the other way of saying this, right? So the nominal interest rate compounded annually is the effective interest rate. This is just the other way of saying it. So this can be right as well, but that's just the other way of saying this guy, right? So, and C is nominal interest rate is only used to express annual compounding interest rate. This is not right. So because nominal interest rate can be used to express non-annually, like daily interest rate, monthly interest rate, or quarterly interest rate. So it's not really right. So, all right, so let's solve an example here. What's the effective interest rate that corresponds to 4% compounded semi-annually? Okay, as we said, the effective interest rate is going to be 1 plus I power of m minus 1. So we need I and we need m, which is compounding frequency, right? So first of all, we need to find I. This is 4% compounded semi-annually. So J is going to be like this. Semi-annually means M is going to be 2. So we find I, which is going to be 0.02. And then now we use this equation, 1 plus I power of M. So it's going to be 1 plus 0.02 power of 2, which is 2 is basically compounding frequency minus 1. So the effective interest rate is going to be 4.04% for 4% compounded semi-annually. Okay, and then how can we use it in calculator method? So let's go to the calculator. 4% compounded semi-annually. So 4% compounded semi-annually. So let's go to nominal interest rate, which is going to be 4% set, and C over Y semi-annually 2 set. And go to effective CPT 4.0.4. Yeah. So 4.0.0.4. Okay. So that's how you calculate. All right, I'll give you 5 minutes for this as well. Calculate the effective interest rate. You don't need 5 minutes for this. I think like 3 minutes is fine. Calculate the effective interest rate that corresponds to 8% compounded quarterly. Okay, 3 minutes for this. All right, so we got people even put the calculation in the chat box. All right, I got a lot of D. Let's see whether D is right. Yes, D is right. Congratulations to you guys. All right, so how we calculate this, as I said, is just use the equation F equal to 1 plus I power m minus 1, right? So we have to find I first. I is going to be J divided by M. J is 8%, so 0.08. Compounded quarterly, which is going to be compounding frequency is going to be 4. So divided by 4, 0.02, and then F is going to be 1 plus I power m minus 1. So you have I here, we put m as 4, and we do the calculation, 8.24%, okay? So how do we do the calculator method? Let's go to the calculator. 8% compounded quarterly, okay? So we are still in that guy mode, but let's just come out of that mode, okay? Let's quit from that mode and then come back again to that mode. As I said, second iconv, second 2, okay? Second 2, it takes you to effective interest rate calculation mode, okay? So what's going to be nominal interest rate? Nominal interest rate is going to be 8%. Enter. What's going to be compounding frequency? Quarterly, right? Quarterly compounding frequency is going to be 4. So compounding frequency is 4. So, and then we want to know what's the effective interest rate. If you go to effective interest rate and push CPT. Push CPT on effective interest rate, it's going to give you effective interest rate for the value which you already set before. You set NOM, you set C over Y, and you come to F and push CPT. CPT is going to give you the values, 8.24, okay? 8.24, yeah? Let's do another example. I'll give you another 3 minutes for this guy. If an interest rate, okay, so this is a little more, not more complicated, but just need to read the question properly, okay? If an interest rate of 1.2% per month, okay? Guys, make sure you understand this, 1.2% per month. Doesn't say 1.2% compounded monthly. It said 1.2% per month, okay? It's not compounded monthly, it's per month. Per month means that it already give you the I. You don't need to calculate the I, okay? I is already given to you, okay? Because as I said, I is periodic interest rate, right? So the interest rate for that specific period is gonna be the I, okay? So if an interest rate of 1.2% per month is charged by a credit card company, what effective interest rate should be disclosed to borrower, okay? I give you another 3 minutes for this for you guys. All right, so all right, so okay, let's look at the answers. We get the letter A, which is true. But let me just, before we solve this question, let me just take you this basically this scheme, this painting over there. So I just want to let you guys briefly refresh your memory about the compound compounding interest rate and basically periodic interest rate. Okay, so when you say 12% compounded monthly, that means 1% per month. Okay, that's just a very important concept. You shouldn't forget that. Okay, so when you say 1% per month, means that it's going to be 12% compounded monthly. Okay, so when they the question they tell you the interest rate is 12% compounded monthly. Okay, then you divide that 12% by 12, like the compounding frequency, and you find 1. Okay, 1%. The 1% is going to be basically you put your money, your $100 there. Yeah, you put your $100 there. And after a month, you're gonna get $101. Okay. And after 2 months, then you put this guy there again, right? So you put this $101 again. You have to calculate 1% of this guy, which is gonna be $1.01, right? So it's gonna be 1.2102.01, right? So it's going to be at the end of month, at the end of the second month, yeah, and so on and so forth, right? So that's how you basically calculate up to 12 months. Okay, at the end of basically at the end of 12 months, you're going to have let's calculate this. Okay, so it's going to be 100 multiplied by 1.01 power of 10. 1.01 power of 12 equal to this, and then you multiply by 100. You're gonna have 112.68. So at the end of the 12 months, you're gonna have 112.68 dollar. Okay, and that's okay. So and your effective interest rate for this guy for 12% compounded monthly is going to be 12.68. Yeah. So that's how you can relate basically the effective interest rate to. So this is effective interest rate. Yeah. So that's how you relate effective interest rate to basically nominal interest rate. That's how you relate together. Okay. So nominal interest rate basically it's happening every period. Okay, every period up to a year. Okay, and you have to find the interest rate per period, which is I, and then you have to use that formula. Okay. So effective interest rate, say, okay, I don't care about this. Just give me how much percentage per year I'm going to receive or I'm going to pay. Okay. So that's how you relate these two guys together. Okay. Did you understand this? Yeah. Any question on this?
No, I didn't understand it. Please, could you go through it again?
All right. So, okay. So, all right. So they tell you that there is, okay. So they tell you you have 12% compounded monthly interest rate. Okay. The 12% is your nominal interest rate. Okay. So this is not, so it doesn't mean after you put $100 in the bank, you're going to get 112 at the end of the year. Okay. Although this is nominal interest rate, but this is compounded monthly. Okay. This doesn't mean that. Okay. This means that you have to find interest rate per compounding period, which is per month here. So you divide this guy by 12. So it's going to be 1% per month. Okay. Yeah. And then at each month, at the beginning of each month, you put your money in, you put your money out. You put your money in, you put your money out. You put your money in, you put your money out. Okay. So at the beginning of first month, you have $100. You put it in. At the end of the month, you get 1% interest. It's going to be 101. Okay. And then again, you put this 101 in at the beginning of the month. At the end of the third month, at the end of the second month, you get 1% of this guy, which is going to be $1.01 added to your principal, which is 101. It's going to be 102.01, and so on and so forth. So you do it for 12 periods, consecutive period. At the end of the year, you're going to get 112.68. Okay. Okay, not 112. Although this is 12% compounded monthly, and you presume that 12% you're going to receive at the year is not true. So the nominal interest rate, when you compound it differently than the year, which is in this case is monthly, it doesn't mean that you're going to receive the exact amount of this after a year. What you get exact amount of after the year is going to be effective interest rate. So with effective interest rate, you will receive 12.68%. Okay, so that effective interest rate, which is 12.68%, is going to be equivalent to 12% compounded monthly. That's what I mean. Okay, and that's how you calculate it here. Okay, do you understand it? Yes? No?
Yes.
All right. Okay, that's good. All right. Any other question, guys? All right, let's go to the question now. Okay, so it said if an interest rate of 1.2% per month. Okay, guys, the question, you have to look at the question carefully, because if it said 1.2% compounded monthly, means is a J. Okay, it's a J, is compounded monthly. But when it said 1.2% per month, means every month you have that interest rate. So you're compounded. So it give you already the I. You don't need to calculate the I. You can calculate the J though, right? So J is going to be 12 times of this, right? So J is going to be 14.4%, right? So J is going to be 12 times of this. So your basically nominal interest rate. It's going to be 12 times of this, right? So let's go for the solution. So they already give you the I. Okay, you already have the I. M is going to be 12 because it's 12 months, right, per year. And then you use this equation, 1 plus I power m minus 1, which ended up to 15.39%. Okay, so that's how basically it's calculated. So the tricky part of this question, as I said, is just 1.2% per month. It doesn't say 1.2% compounded monthly. If it said compounded monthly, then it's going to be J. This guy is going to be J. If it doesn't say it's compounded monthly, it just said per month, it is I. Okay, it's important to just notice that. Okay, and then in calculator method, we first of all, if you want to use calculator, we need to find J. Okay, J is going to be like the nominal interest rate is going to be 12 times of this guy, which is 14.4%, and then now we can use the calculator. Let's go to calculator. In this case, we have 14.4% as nominal interest rate. So let's go there. Nominal interest rate is going to be 14.4 set, and then compounding frequency is going to be 12, right? So C over Y is 12 set, and then we go to effective interest rate. Put CPT 15.38. So 15.38. 15.39%. It's going to be your compound annually. Okay, why 15.39? Because we run this 8 to the nearest number based on this number. Okay, 15.39. All right, so another question. I give you 5 minutes for this as well. At what effective interest rate will $8,000 grow to $13,663.19 in 6 years? Okay. This question is basically interesting because this question is so you just need to know what's the concept of effective interest rate is, right? So it's going to be interest rate is compounded annually, right? And the rest of the question is related to something which you learned last week, right? They give you present value, they give you future value, and give you the time. So you need to find the interest rate. So you need to use different formula, right? So I'll give you 5 minutes for this.
Excuse me, Prof. Hello.
Yes. Did you ask a question? Yes. Did you ask a question?
What is the compounding frequency they didn't mention?
For effective interest rate, compounding frequency is going to be 1, right? So effective interest rate. Effective interest rate is nominal interest rate compounded annually, right? So the compounding frequency for this is going to be 1, right? All right, 3 more minutes, guys. All right, we got the letter A. Let's see what the answer is. Yes, A is right. All right, so in this example, we have basically a present value, we have future value, and then we have time, right? And ask us for what interest rate is, right? So, uh, so what I do personally to solve this problem, okay, Let me just bring you the paintbrush again. Just let me clear the whole thing here. Clear. So I personally do this. I have the equation FV equal to PV multiplied by 1 plus I power of M N, yeah. I personally just put the stuff in the same equation and then find I need the I, right? So I need the effective interest rate. So I personally how I personally solve it. I put $13,000 here, 660 whatever here, 663.19 here, equal to 8,000, 1 plus I power of N. N is 6 years, 6. And since it's compounded annually, M equal to 1. So it's going to be 6, power of 6. And then I solve for I here, okay? So I is going to be, so this guy, this divided by this, so I is going to be basically, if you know a little bit of algebra, it's going to be 13,663.19 divided by 8,000 power of 1 over 6, right? Minus 1. Yeah? So you divide this guy by this guy, divide the 13,000 by 8,000, and then you have to 1 over 6, right? So to get rid of power of 6 in front of I, and then you have 1 plus I, and then you do minus 1. So this is how I personally solve it. Okay, if you have a little bit of linear algebra in your mind, you can really fastly do this. Okay, otherwise you need to use the formula sheet, and the formula sheet say I is equal to, this is last week session, last week course, right? It was FB divided by PV power of 1 over N. This is last week course, right? Minus 1. You can use this one as well. This is a formula sheet. But I personally like to do this. I keep the original formula in my mind, memorize it, and then whatever they give me, I put in the formula and isolate it for the unknown. Okay, so that's what I do it personally. But you guys probably more like to do it more in terms of formula sheet. You have a formula sheet in front of you and know which one you have to use. Okay, so it's up to you. But I personally prefer just remember one formula and put everything in one formula and use some linear algebra to solve it. Okay, it's just up to you guys. All right, so the way we solve it in PowerPoint is just using the cheat sheet, basically the formula sheet of FV divided by PV1 over N minus 1. We have future value, we have present value, we have N, which is number of years, which is going to be 6 multiplied by 1, the compounding frequency, and then we use it all together in this equation. And how do we calculate this? As I said, let's calculate this guy. Okay, so we divide this guy together, power of this guy. Okay, so let's do this also in calculator. Just make sure that you're familiar with the calculator. Let me squeeze this mode, and 13,663.19 divided by 8,000. 13,663.19 divided by 8,000 is equal to this number, 1.7. Store it in number 1, and you have 1 over 6. 1 divided by 6 equal to, and you store it in number 2. Yeah. So number 1 power of number 2. Recall number 1 power of recall number 2 equal to this 1.09. Okay, and your minus 1 is going to be 0.0933, and if you multiply it by 100, it's going to be 9.33% effective interest rate. Much easier way to solve this using calculator. It's much easier to do it in calculator because calculator have all this functionality in itself, right? So we wanna find what's the what's the effective interest rate, nominal interest rate component annually, right? So we have the present value, we have future value, we have time. Okay, so let's do this in the calculator. Let's clear everything here and clear the work here, and now using the calculator functionality, we have $8,000 grow to 13,663.19. Okay, so $8,000 is going to be present value, $8,000. Make sure you put the negative sign, guys. Just make sure the sign for present value and future value has to be different. Okay, make sure that. Okay, and then future value is the 13,663.19. 19 is going to be the future value. And now what's the compounding frequency? You want to find the effective interest rate, right? Effective interest rate compounding frequency is going to be 1, right? The compound annually. So let's go to P over Y and set it to 1. It's already set, and quit this mode. So now you set this, you set this, you set this. We need to find n. N is going to be 6 multiplied by compounding frequency is going to be 1. So 6 is going to be n. Yeah. So now the only unknown in this equation is I over y. So we do CPT I over y, 9.33. Okay. So 9.33 is going to be nominal interest rate, compounded annually, which is effective interest rate. So nominal interest rate, which is compounded annually, is effective interest rate, as we discussed. Okay. All right. This is the last question for today. Marcus went to the bank and obtained a personal loan with the interest rate of 5% compounded monthly. If the bank decided to deduct 2% from the effective interest rate, calculate the new interest rate compounded monthly. Okay. I give you guys 5 minutes for this. All right, let's see what people did here. A lot of A here. Let's see. It's going to be B. Okay. All right. So, okay. So let's solve this problem. Okay. All right. So first of all, we need to find what's the effective interest rate related to 5% compounded monthly, right? So first of all, we need to find the effective interest rate for this guy and then deduct 2% from it. Okay. It's going to be new effective interest rate. And then for that new effective interest rate, we need to find what's going to be the nominal interest rate compounded monthly. Okay. So there is a back and forth. You back and forth. First you force, you go find the interest rate, and then you back again to the compounded monthly. Okay. So there are two-step process. One step, the first step, you find the effective interest rate. Second step is from that effective interest rate, from the new effective interest rate, you come back to the nominal interest rate. So it's a back and forth. Okay. First of all, let's find what's going to be the effective interest rate for 5% compounded monthly. Okay. That's easy. You have basically compounded interest rate, compounded monthly. You have 5% divided by 12. It's going to give you I. Okay, you have I here, and then you use this equation for effective interest rate. Effective interest rate is going to be 1 plus I power of m minus 1, which is going to be 5.11%. Okay, and 5.12%, right? So and then now this is effective interest rate, and said if the bank decides to deduct 2% from that effective interest rate, from this effective interest rate, you have to deduct 2%. Okay. So you have new effective interest rate, which is going to be 3.11. Okay. And for this 3.11, they ask you what's going to be the compounded monthly interest rate for this new interest rate. So this is now the back side. Okay. So you need to, from this effective interest rate, you need to find I. Okay. All right. How you can do it? You can use this equation, right? So you can use the equivalent interest rate equation. This is one option. The other option is that you can use this equation. You just put this as 3.11% and put this guy as 12, right? And you find I. You find I with some linear algebra. If you're familiar with linear algebra, it's going to be much easier to use the effective interest rate equation rather than equivalent equation. So, but anyway, so if in the equivalent equation, right now you have effective interest rate as a as a new quantity, and M1 is going to be 1 year, M2 is going to be 12. You put it there, and you will find I2. Okay, so I2 is going to be 0.0256 per month, and as we said, you have to convert it to year, which is going to be 12 times by this. It's going to point 3.07%. It's going to be your nominal interest rate compounded monthly. Okay, so that's how we calculate the basically J2. Okay, if we want to use calculator method, actually it's much easier to use calculator method. Why? Because it's just the whole thing is built in calculator, right? So 5% compounded monthly. So let's do that. So 5% compounded monthly, you want to find what's effective interest rate. Okay. So we go to calculator again, and let me just clear everything in the calculator. Clear work, CE. Now we go to icon mode, right? So the effective interest rate mode calculation. We have nominal interest rate of 5. Enter, and then we have compounding frequency of 12, right? So monthly, yeah. And now we want to know what's the effective interest rate. You go to effective 5.11, 61, 89. Okay, so from this number we have to deduct 2%, right? Based on the equation. So 2% we have to deduct. So 5.11, let me clear the work. Just quit this mode. 5.11. What was the name? 61 minus 2 It's got to be 3.11. This is going to be our new 3.1161. Okay, that's going to be our new effective interest rate. So let's go back to account mode again. The effective interest rate for this guy is going to be this guy minus 2, right? So 3.116189. 3.116189 is going to be a new effective interest rate. And then compounding frequency is going to be 12, right? And we want to know what's going to be for 12 compounding frequency. And now we go to nominal interest rate and we put CPT. Calculate the nominal interest rate, 3.0725. Okay. So, and now this is to 3.725. Okay. So 3.07% is going to be the nominal interest rate, which is equivalent to 3.11% effective interest rate. Okay. All right. So any question until now, guys? Any question? This question was a little bit difficult, I understand, because you have to use two different equations. First, the equation for calculating the effective interest rate, and then the equation which we learned the first part of this lecture to calculate the equivalent interest rate. So you find the effective interest rate, and from that effective interest rate, you find equivalent interest rate for basically to find the nominal interest rate for compounded monthly, right? So it was two equation, one back and one forth. Back was just you calculate the effective interest rate, and then you back again from effective interest rate to find the nominal interest rate. So it was a little complicated, but if you just practice it a little bit, practice the different questions in mock tests and here and there, and then you get familiar with these sort of questions. Okay. Any question? Any question, guys?
Yes, hi, Professor.
I barely can hear you.
Hello?
Yes, but I can barely hear you. Hamanshu, are you talking? Is that Hamanshu?
No, sir, I am not.
It's me, Sheikh.
Okay, can you get closer to the microphone? I can hear you, what you say.
Yeah, I'm in the microphone. Very
Yeah. Yeah, what did you say?
Yeah, so my question is that I couldn't find any recording video on my Zoom profile.
For this video or next video or last video?
Last video, like from first to till, I didn't get any video.
I explained it. I explained it just before we start.
Yeah, I checked it, but there is no video. So can I share my
you
screen?
have to go to the Seneca Zoom, right? Seneca Zoom.
Yeah, I went.
And then you find you have to go with your own account. You can't go with you have to go with your Seneca account. You can't go with your personal account. I presume you went to Zoom with your personal account. So you need to go with your Seneca account. So if you go to the Zoom with your Seneca account, Seneca.ca, you see Seneca.ca zoom.us. If you go this, then you log in with your Seneca credit. Then you can just go to recording and find the meeting ID. For that meeting ID, find recording. Okay, just make sure you go with your Seneca account.
I go that, but there is nothing. Can I share my screen?
Does everyone else also have the same problem, or people do people have the same problem as well, or only Yasin has problem? Everyone else has the same problem, or Yasin has this problem? Okay, so you can see the recording. You see the Musadik said that he can see the recording. So it can be your problem. So what I can do, I can send you the link for the recording after we finish this lecture. I can send you the link for the recording, and then you just click on that link, the direct link. Basically, I can send you the direct link for recording. I can do it right now, I guess. Let me see if I can do it right now.
Sorry to interrupt. Sorry to interrupt, sir, but I also can't see any kind of recording.
Let me just go here and then send you the recording here. I'm just gonna share you this, share, copy. I'm going to copy this and then paste here in the chat box. Yeah. Paste in chat box. It's not in the meeting. That's fine. But why it doesn't? Oh no, it's not Cherry. Everyone in the meeting. Yeah. All right, so I copied in the chat box. Okay, so and the passcode is the one which you see it here. So this I shared this. Okay, just click on it if you don't see it again, and then let me know. Okay. Let me know if you had problems still. Okay. If you still have problem, but some people can see it, some people cannot see it. So I would recommend people who can see it just guide through the other people who can't see it.
I have sent a screenshot, so can you please check it on the chat box?
Only host can download this recording. Oh, okay. That's kind of inconvenient, though, right? So, all right. I'm gonna ask the. Okay, so I'm just gonna keep this. I'm just gonna save this somewhere, and then I will ask the. Then I will ask the supervisor to have a look at it. Okay. I will send you guys also. I will send you guys also the. I will send you guys also the information for that. Okay, just remind me of this that I follow up with this. Okay, but it's so weird that it's only host can download the recording, but download is probably host. But what about the seeing the recording, not downloading it? Is that you can't even see it? You can see it.
When I open the link that you sent, it just shows me this.
Oh, this one? Oh, yeah, the one which I send you. Does it need the passcode? It said the passcode right there, right? The passcode is. It doesn't even ask you for the passcode, huh?
Yes, sir.
Let me. Okay, let me do the other way. Detail. Let me just send you this. This. Oh, let me send you this. Okay, let me send you. Share. Copy. And then share. Can you click on this and see whether you still have the same problem?
Yes, sir. Now it works.
Now it works?
Yes, sir.
It works? All right. So I don't know what we can do. I don't. It's pretty inconvenient if I wanna send you the links all the time. But let's see what we can do. It's just I just don't want to do that every time that we have a meeting. Let me go here. It's very inconvenient. It's very inconvenient that I have to do it myself. But let's let's do this for the today meeting. I'm just gonna post it here for today meeting, that you don't be hanging around here and over there. So after I finish this this meeting, you can just click on this on the link which I send you in the chat box for this meeting, for this current meeting. So you can find the video for this. So but it's pretty inconvenient if I have to do it every time. That's so weird that you don't have the that you can't log into the Zoom account and look at the recording. So I will ask the session manager, basically my manager, to see how can we solve this problem. Okay, and if we can't solve this problem, then I'm gonna put in announcement. I'm gonna put the shared link like this link for all the past session. Okay, so in announcement I'm gonna put basically all the recording of the previous weeks with the shared link similar to this one, so that you can just click on it and go basically to the video without any password or something like that. Okay, I will do that after this class. So I'm just gonna put it on the announcement, all the Zoom meeting which we had before, all the recordings. I'm gonna put an announcement. Okay, I'm just gonna do it after this meeting, after this class. Okay, sounds good.
Yes.
Yes, no? All right, okay, good. All right, another question. Oh, okay, so one more thing, guys. Please, I don't wanna emphasize it too many times, okay? Test 1 is next week, okay? So February 6th is gonna be open, like Monday, and it's gonna be closed on Thursday night, okay? And this is serious, guys. You have to take this test. And this is 25% of your final mark. And also before that, please do some mock tests before, so that you get familiar with it. And also lab 3 and lab 4 also due in next week, right? So lab 3 and 4 also need to be done, okay? Please do that as well. Next week, please bring your questions. So next week's session is going to be only questions and answers. Bring your questions. Any question you have, bring it to the class. We share it with the class. We solve it together. We get familiar with it, okay? And you have until Thursday night, okay? So you can probably wait until next week's session and then take your test next week after the class, so that you also get more comfortable with the question and answers, and also basically the mock test. Okay, you can probably do that, or you can do it before the class. It's up to you. But next week class is going to be on. We are going to be focusing on test 1, basically questions and answers. Okay. So yes, please take it seriously. It's going to be a little bit hard on you guys, but you have to be basically diligent about it. Okay. Any question, guys?
Excuse me, will the test include all the lessons we have done until now?
Yes. Yeah. You go through the mock test. When you try the mock test, you see all the lessons which you learned until now. It's going to be there. Okay. So
Okay.
yes, it's going to be all the lessons we learned until now. Okay. Yeah. Any other question?
Okay. Thank you.
Any other question, guys?
No question. Thank you, Professor.
All right. Thank you very much, guys. Okay. You have a good weekend, and see you guys next week. Okay. I'm gonna put the link for the Zoom room recording in the announcement. Okay. All right, guys. Okay. Have a good night.
Thank
Have
you,
a good day.
Professor. Bye-bye.
All right, bye.
Thank you, sir.
You.